Hello students, welcome to the video class of the new chapter, that is three-dimensional geometry, coordinate geometry. Before that we should refresh our minds. Let's do Brahmanath. Om Shanti 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 Swastha. In last class we discussed the vector, okay, that is the fundamental of vectors, dot products and cross product, etc. Today we are going to discuss three-dimensional coordinate geometry, that is geometry studied in space using algebra is called coordinate geometry. Okay, in two-dimensional geometry there are two axes, but in three-dimensional geometry there are three axes, namely x-axis, y-axis and z-axis. So what do you mean by coordinate geometry in three-dimensional coordinate geometry? Definition: geometry studied in space using the algebra or using the order triplet. Geometry study in space using the order triplets. That is what? X, y, z is known as three-dimensional coordinate geometry. Clear? Geometry studied in space using the order triplet x, y, z is known as three-dimensional coordinate geometry. What is the rectangular system of three-dimensional geometry? Three-dimensional system. Three-dimensional system. Okay, there are three mutually perpendicular lines. Three mutually perpendicular lines XO, that is what? Three mutually perpendicular lines XO x dash, YO y dash, and ZO z dash intersect at a point O called origin and divides the space into 8 parts called octant. Okay, this is what? Suppose this is x-axis. This is what? X-axis, and this is y-axis. This is what? This is x-axis and y-axis. Here, suppose this is x-axis and suppose y-axis, and this is what? Z-axis. Like this. Suppose this x-axis, y-axis and z-axis like this. suppose this is what? Suppose this is x-axis and this is y-axis and this is z-axis. Okay, so similarly here x dash, this is y dash and this is z dash. Clear? So in figure this is not possible draw on the plane. Suppose this is say x-axis and this is y dash x y and this is what? X dash and this is y o and this is y dash. Suppose z-axis is like this, z-axis is like this towards us, or we can draw here that is what? X-axis and this is what? Suppose z-axis is like this. Okay, this line is towards us. Okay, and this is what? X dash and this is y dash and this is what? Z dash. So the three mutually perpendicular lines x o x dash, y o y dash, z o z dash intersect at a point called origin and divides the space into 8 parts called octants. Okay, where x o x dash, y o y dash and z o z dash are called coordinate axes. The coordinate axis makes 3 planes on the space, in this space. Okay, coordinate axis make 3 points on the plane, in this space. Okay, then write that coordinate planes makes 3 planes on the plane, on this space. Coordinate axis makes 3 planes, in space, namely xy plane, yz plane and xz plane. Okay, so this is what? This is suppose x-axis and this is y-axis. This plane is called xy plane and this xy, this is z. So this plane is called, my palm is here, it is what? Xz plane and this is yz plane. Clear? So this is like this, this is like this. Okay, this plane is called, suppose this x and y and this z. This plane is called xy plane, and this plane is called what? YZ plane, and this plane is called what? Like this. This plane is called XZ plane. This plane is called what? XZ plane. This is XZ plane. Clear? X dash, y dash, z dash indicates the negative part of x-axis, y-axis and z-axis. X dash, y dash, this is x dash, suppose x dash, this is y dash, suppose y dash, and this is what? Z dash, suppose. X dash, y dash and z dash indicates negative part of negative part of x-axis, y-axis and z-axis. Okay, so in there is location of a point. These three planes are called what? Coordinate axis makes three planes in space: x, y, y, z plane, z x plane. These are called coordinate. That is coordinate planes. These are called what? Coordinate planes. X, y, y, z and x, z planes are combined called as coordinate planes. Okay, coordinate planes. Now what is the coordinates of the point in different coordinates? Suppose this is origin, so, and this is z axis. Clear? That is x o y. This is called what? X o y z is called first quadrant, so it is all positive. Okay, that is there are. Now what are the octants? Now we'll discuss about octant. Now the octants are octants. What are the octants? That is what? This is x-axis, y-axis and this is z-axis and this is z-axis. This is origin and this is called x o y z. That is what? X o, that is o x y z. We can say o x y z is called first octant. That is octant. Suppose this is octants, and this is what? Coordinates. O x y z. That is coordinates here x y z. So all positive, plus, and this is what? O x dash y z. This is what? Minus, plus. Again, this is equal to what? Now O x y dash z plus, minus, plus, then O x y z dash. This is what? This is equal to plus, minus, and this is equal to what? Again O x dash y dash z. That is minus, plus, and this is equal to O x y dash z dash is equal to what? Plus, minus, 1 2 3 4 5 6, and this is 7. That is O x dash y z dash. So minus, plus, minus. Again this is what? This is O x dash y dash z dash, minus. So octant, there are 8 parts here. 1 2 3 4 5 6 7 8. These are octants and the sign of the coordinates. Okay, now location of a point in 3D space. Now location of a point in space. Okay, location of a point in space. Clear? So this is suppose x, o, y, and this is z axis. So location, suppose this is the system is like this, and the point is here, and the point is here. So suppose this is the point is P of x, y, z in the space. Okay, so suppose this is point. Draw from x unit here, and draw from y unit here, and draw from z unit here. Okay, so this is what? X, and this is y, and this is what? Z, like this. So this is like this. This is suppose z axis, and the point is here. That is, the point is here. This is the point P. Clear? This is the point P of x, y, z in the space, P of x, y, z, which is in the space, and this is x, y plane, z coordinate 0. So this is x, y 0, and this is xz plane, y coordinate 0. That is x 0 y, and this is what? This is x axis, so x 0 0, and this is y axis, so 0 y x 0, y axis, so 0 y 0, and this is what? Z axis, so 0 0 z, and this is what? YZ plane, means YZ plane means what? X is equal to 0, x y 0, this is YZ plane, so x is equal to 0 y z, and this is origin 0 0 0. Okay, these are the location of points in 3-dimensional geometry. So what is the distance of the point from the figure? Distance, this is y distance. Okay, so y distance, the point is located at y distance from xz plane. So let P of x, y, z be a point in space. Now mode x is equal to what? Mode x is equal to the distance. Mode x is equal to the distance of the point P of x, y, z from what? From x, what is mode x? This is equal to mode x. This is equal to what? Mode x from yz plane. Clear? Similarly, mode y is equal to the distance of the point P of x, y, z from xz plane, and mode z is equal to the distance of the point P of x, y, z from xy plane. These are the coordinate system, that is location of a point in space. Okay, then coordinates of origin. Note, coordinates of origin in 3D system are 0 0 0. Okay, that is now coordinates of the coordinate axis. Any points, note to any points on x-axis is what? X 0 0. Number 3, any points on y-axis is 0 y 0. Number 4, any point on z-axis, that is 0 0 z. Number 5, any points on xy plane, x comma, that is x comma y comma 0. 6, any points on yz plane, that is what? This is 0 y z. And 7 is any point on xz plane. So this is what? Xy means xy 0, xy plane means what? Xy 0, yz plane means 0 yz, and xz plane 1 means what? X 0 z. Clear? This is the 3D system, and what is the equation of xy plane? Here equation. Now equation of y axis, that is y equal to 0, and this is z is equal to 0, this is x equal to 0 and z equal to 0. Equations of number 1, xy plane, x-axis, this is equation of x-axis is what? X-axis, the equation of x-axis here, y equal to 0 comma z equal to 0. Number 2, y-axis is x equal to 0 comma z equal to 0, comma 3, and this is what? Z-axis is x is equal to 0 comma y equal to 0. Number 4, equation of xy plane is what? Z equal to 0. Number 5, equation of yz plane is x is equal to 0. Equation of xz plane is y equal to 0. xy z0, yz x0, xz y0. Okay, these are the equations of the coordinate system, that is coordinate axis and coordinate planes. Now distance formula. What is image? Image of a point with respect to xy plane, or we can say what is now foot of the perpendicular drawn from the point, on x-axis, y-axis, z-axis, and on xy, yz, xz planes. Now foot of the perpendiculars. Foot of the perpendicular perpendicular drawn from the point P of xyz number 1 on x-axis, foot of the perpendicular drawn from the point P of xyz on x-axis, that is what, x comma y comma 0 comma 0. Okay, this is the point. Suppose P of xyz and this is x-axis. On x-axis both y and coordinate z coordinate 0. This is what, x comma 0 comma 0. This is 3D figure, not 2D figure. And this is number 2 on y-axis. This is equal to what, 0 y 0. On z-axis, what is here, 0 0 z, 0 0 z. This is now on xy plane, z coordinate equal to 0. So 0 0, sorry, z coordinate 0, x comma y comma 0. On yz plane, that is what, on yz plane, this is yz, 0 yz. On xz plane, that is what, x 0 z. These are the foot of the perpendiculars drawn from the point P of xyz upon x coordinate planes and coordinate axis. Now image of the point. Now image of the point P of xyz, image of the point P of xyz with respect to number 1, with respect to xy plane, that is what, xy minus z. Okay, number 2 with respect to yz plane. With respect to yz plane means what, minus x yz. And with respect to what, with respect to xz plane, that is x minus y z. Okay, this is suppose the coordinate system, and this is what, z axis. This plane is called what, xy plane, and upper side is z, lower side is minus z. So its image is below this is above the xy plane and this is below the xy plane. So this is plus z and this is minus z. That's why the image of the point xyz with respect to xy plane is what, xy minus z. Got it? Again, distance formula. Now distance between 2 points, distance formula, distance of the point, distance between the point, distance between the point A of x1 y1 z1, A of x1 y1 z1 and B of x2 y2 z2, B of x2 y2 z2 is given by AB distance is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is the distance between 2 points. This formula is applied to find the distance between 2 points in 3-dimensional system. Now note distance of the point, distance of the point x y z, distance of the point x y z from origin is equal to what? Root over x square plus y square plus z square, because x2 minus x1, that is x minus 0 square, that is x square, y minus 0 square, that is y square, and z minus 0 square, that is z square. Note 1, this is note 2, distance of the point P of xyz from what? From x-axis is equal to root over y square plus z square. Why it is obtained? So this is suppose xyz and this is x-axis. Okay, any point on x-axis, that is what? X comma 0 comma 0. Now apply distance formula, that is x minus x square, that is 0 square 0, and y minus 0 square, that is y square, and z minus 0 square, that is z square. Similarly, we get distance of the point what? P of xyz from y-axis is equal to what? X square plus z square. Finally, distance of the point, that is distance of the point P of xyz from z-axis, P of xyz from z-axis, which is equal to what? Which is equal to root over x square plus y square. These are the distance formula. Okay, now division formula or section formula. This concept which is discussing are the first year concept, that is 11th class concept. So I want to remind this concept of class 11th. So watch and observe observe. Now this is the distance formula. Now division formula. What is division formula or section formula? Division formula or what? Section formula. Division formula or section formula, that is first one is internal division. Internal division means, suppose this is a line segment AB and the point is what? X1, Y1, Z1, and this is X2, Y2, Z2. The point P divides, suppose the point P divides in the ratio what? M is to N. Let the point P divides the line segment AB in the ratio M is to N internally. Then the coordinates of the point P, then the coordinates of the point P is given by, this is multiplied this and this is multiplied this, mx2 plus nx1 divided by m plus n. Similarly, for y coordinate, this is my2 plus ny1 divided by m plus n, mz2 plus nz1 divided by m plus n. This is internal division. Now external division. External division. The point is outside. The point P is outside of the line segment FB. This is suppose A and this is B, whose coordinates is given by x1, y1, z1, and this is x2, y2, z2. And the point P is like here. So whole is what? M, and this is equal to n. Now the point P divides, if the point P divides AB in the ratio m is to n externally, then coordinate of P, then coordinates of P, then the coordinates of P is equal to what? P of, that is P of my2 minus my1 divided by m minus n, and comma, this is what? And this is suppose here n, correct? And y coordinate is here, sorry, this is x coordinate, the point P of what? mx2 minus nx1 by m minus n. This portion, whole portion is what? M, and this portion is suppose n. So y coordinate equal to my2 minus ny1 divided by m minus n, and z coordinate equal to mz2 minus nz1 divided by m minus n. This is external division. Okay. Now midpoint of the line segments. Midpoints of the line segments. Midpoint of the line segment, suppose this is what? A of x1, y1, z1, and this is B of x2, y2, z2. Suppose this point is midpoint, M is the midpoint. Okay, the midpoint of line segment, the midpoint of the line segment, joining the points, line segment joining the points, A of x1, y1, z1, A of x1, y1 and z1, and B of x2, y2, z2 is given by, the midpoint is what? x1 plus x2 by 2. x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. This is the midpoint formula. Clear? And what is the centroid of the triangle? What is the centroid of the triangle? Now centroid of the triangle with what it says, x1, y1, z1, x2, y2, z2, and x3, y3, z3. Centroid of the triangle. Centroid of the triangle. Centroid of the triangle. Let A of x1 y1 z1, B of x2 y2 z2, and C of x3 y3 z3 are the centroid vertices of triangle ABC, then centroid of the triangle ABC is x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. This is centroid of the triangle. Now centroid of the tetrahedron, let x1 y1 z1, x2 y2 z2, x3 y3 z3 and x4 y4 z4, x4 y4 z4 are the vertices of a tetrahedron, then centroid of the tetrahedron, centroid of the tetrahedron, centroid of the tetrahedron is equal to what? x1 plus x2 plus x3 plus x4 by 4, comma y1 plus y2 plus y2 plus y3 divided by 4, comma z1 plus z2 plus z3 plus z, this is y4 here, so this is what? y3 plus y4, clear? Divide by what? 4. Similarly, z1 plus z2 plus z3 plus z4 divided by 4. This is the centered formula for tetrahedron. Okay, these are all about the fundamentals of the coordinate geometry, which is syllabus of what? Class 11th. Up to this, the fundamentals are class 11th. Now for class 12th, let's discuss what is direction cosines, what is direction ratios and applications. Okay, direction cosines of a line. Direction cosines of a line. Direction cosine of a line, in shortcut it is also written as DCS of line, means direction cosines of a line. What is direction cosines? It is the angle made by the coordinate axis. Suppose alpha, beta, gamma are the angles made by the coordinate axis with positive directions. Coordinate axis, okay, alpha, beta, gamma are the angles made by a line with the coordinate positive direction of coordinate axis. Then its cosine form is called direction cosines. Suppose this is what? This is what? This is the coordinate system. This is origin, this is x-axis, this is y-axis, and this is z-axis. Suppose a line here, this is line, this is suppose a line, any line here. If this makes with x-axis alpha angle, and this is what? Beta angle, and this is what? Gamma angle. Then cos alpha, cos beta, cos gamma are called directional cosines. What is definition of the directional cosines? If alpha, beta, gamma are the angles made by a line with positive direction of x-axis, y-axis and z-axis respectively, then cos alpha, cos beta, cos gamma, are called DCS, direction cosines, DCS of a line, and denoted by simply L, M, N, or we can write in brackets L, M, N, this bracket. Okay, this bracket used for direction cosines, or you can write L, M, N. Okay, or you may write L, M, N. Clear, simple L, M, N. Or if you put the bracket, then this should be what? Like this bracket. That is what? L equal to cos alpha. That is what? L equal to cos alpha. L equal to cos alpha. M equal to cos beta. And N is equal to cos gamma. N equal to cos gamma. Okay. Now one question, that is example question. If a line makes 30 degree, 60 degree and 90 degree with x-axis, y-axis and z-axis respectively, then the DCS, direction cosines, are of line R dash, So what is solution is here? Alpha is equal to 30 degree, beta is equal to 60 degree, gamma is equal to 90 degree. So L is equal to cos alpha means 30 degree, and beta is equal to cos 60 degree, and gamma is equal to cos 90 degree. So cos 30 is equal to what? That is L equal to root 3 by 2, M equal to what? Half, N is equal to, and this is L, M, this is M, correct? M, and this is what? N. So L is equal to root 3 by 2, M equal to half, N is equal to 0. So DCS are what? Root 3 by 2, 1 by 2, 0. Okay, now relation between the coordinates of a point and DCS. A relation between the coordinates XYZ, coordinate XYZ with respect to, or relation between the coordinate XYZ and DCS, DCS of line passing through origin and that point and the point x, y, z. Okay, relation between the coordinates, that is x, y, z, and DCS of the line passing through origin and the point x, y, z. Suppose this is what? This is the coordinate system. This is x, o, y, y dash, z. Okay, and the point is here like this, the point P, suppose here x, y, z. Okay, and if the this is alpha and this is beta and this is what? Gamma. Let P of x, y, z be any point and let OP DCS of OP. Let DCS of OP are LMN, that is what? Alpha, beta, gamma are the angles made by what? Angles made by OP with coordinate axis. Okay, coordinate axis. In triangle, suppose this is O and this is M and this is O. In triangle OPM, what is cos alpha? Cos alpha is equal to what? Cos alpha is equal to, this side is what? This side is, and this is x, and suppose this is OP length equal to, suppose R. Okay, in triangle OPM, this is what? Let OP distance is equal to R. R means what? Root over x square plus y square plus z square. Now in triangle OPM, cos alpha is equal to B by B, OM by, that is OP. So OM, that is what? X by R. That implies what? That implies L equal to x by R. Similarly, we can derive. Similarly, we can derive M equal to y by R. N is equal to what? N is equal to z by R. This is the relation between DCS and coordinate of the point. So or we can get x is equal to LR, y is equal to MR, and z is equal to what? Z is equal to NR. This is the relation between the DCS and the points x, y, z. Now, what is the property of DCS? Properties of DCS. Direction cosines of a line. If L, M, N be the DCS of a line, then the property is L square plus M square plus N square is equal to 1. This is the property. Okay. Suppose proof that is what? This is x axis, this is y axis, and this is z axis. Suppose this is O and this point is P. Suppose this x, y, z, and this is alpha, and this is beta, and this is gamma. we know L is equal to x by r, m is equal to y by r, n is equal to z by r, where r is equal to power x square plus y square plus z square. Now left hand side LHL, left hand side L square plus m square plus n square. So that is x square by r square plus y square by r square plus z square by r square. So r square LCM x square plus y square plus z square, that is equal to r square by r square goes cancel. This is 1. Okay, this is the property of the DCS. Now these are the some concept of the three-dimensional geometry. In next class we will discuss the direction ratios and the relation between direction ratios, some angle between two lines, etc. Thank you. Have a nice day.